Hello YouTube. In this video we're going to be discussing the basics of algebraic and numerical expressions, okay, and specifically numerical expressions. We say that these are things that consist of numbers, operations, and grouping symbols, okay. I want to kind of distinguish between a numerical expression though and a numerical sentence. We say a numerical expression is different from a numerical sentence, which consists of one or more expressions involving either equal signs or inequality signs. So when we talk about a numerical sentence, we're talking about more than one expression, but we're kind of involving equal signs or inequality signs and comparing them, okay? So in this section, this video is kind of going to be about exponentiation, raising to a power, but we're going to talk about the difference between an expression and a sentence, okay? So we say expression, here's what we know about an expression. It involves grouping symbols, operations, okay, from above. Oops, I don't need two S's. And numbers, okay? And what I'm going to tell you is this. An expression is different than a sentence, okay? And that a sentence is the same as, well, let's just put it this way. It contains expressions. But the important thing to note here is this. It has equal signs or inequality signs, okay? And so one thing we're going to notice as we read through a lot of verbal models, you look at a lot of verbal models in algebra, is that sentences that involve inequality signs or equal signs often involve like complete thoughts, so like a complete sentence, okay? So we're going to look at exponentiation, as I mentioned here. So we say exponents are used to represent repeated factors in multiplication. So it's kind of like repeated multiplication. Something times itself a set number of times. So I give as an example here 2 to the 5th power. We say 2 to the 5th power can be re-represented this way. And I'm going to kind of give some advice here in this video, but we say 2 to the 5th power. Let's go over some vocabulary here really quickly. 2 is referred to as the base, okay, of this exponent. We kind of think it is on the ground here. And we say 5 is the power. It is also referred to as the exponent, okay. But when we talk about repeated multiplication, what this is really communicating to us here is that we have this exponent, we have this many factors of the base that it's connected to here. So we have 5 factors of 2. So, 2 to the 5th power is kind of a convenient way of writing 2 times itself 5 times. And so since we're going to be doing this so often, I kind of wanted to explore a few expressions down here. And of course, we notice that these are expressions right now because even though they contain equal signs, there's nothing on the right side. So like negative 2 to the 4th is, that's an incomplete thought. That'd just be an expression. But let's take a look at these expressions down here. Let's turn them into sentences by completing the thought. So I would say take a second to pause the video and kind of maybe consider all these, but we're going to go ahead and evaluate them now together. We say negative 2 to the 4th power. Now this would be the same thing as if you wanted to see a concrete example of what this means. Negative 2 times negative 2 times negative 2 times negative 2. What I want to notice here that is important is that this negative was included in the parentheses. So when we multiply it here, we have to multiply by itself, which makes a difference because a negative times a negative is a positive. And we see that we have 2 pairs of positives. So 2 times itself 4 times is 16, but we say we have a positive 16. Whereas if I were to look at this example over here, we say that this 3 to the 3rd, it's technically the only thing that exponent 3 is attached to is the base 3. This negative is out front. This could be re-represented as negative 1 times 3 to the 3rd power, and it means the same thing. So we have to be careful here, because when we do the order of operations, of course, we would say 3 to the 3rd first. We say 3 times 3 times 3. And really, this could be re-represented as, when in doubt, write it out this way. And this would be, of course, 3 times 3 times 3 is 27, but we have that negative 1 there, so negative 27, okay? And so these last two examples, just kind of to show you the difference here, it's really important whether we include the negative inside the parentheses or not, but we say this would be negative 4, 2 factors of negative 4. So this would equal a positive 16. And then this one over here, we'd say this would be negative 1 times 4 because this 2 is only concerned with the 4. So we would actually get a negative 16 in this instance. But that's how you would use exponentiation, and that's how the format goes. Cheers.